It shouldn't exist. A perfect circle sits on the seafloor, 90 meters down. No erosion, no randomness, just geometry. Sonar reveals edges too clean for nature. A trail stretches behind it, straight, precise, nearly 300 meters long. Something moved here, fast, heavy. Then it stopped. Nothing in this sea should behave like that. Not here, not ever. So what carved that path, and what waits at the end of it? The Baltic Sea hides thousands of wrecks. Wood survives for centuries in its cold, brackish water. Ships sink and freeze in time, but this isn't a ship. It doesn't decay, it doesn't splinter. It remains, silent, intact. When the first sonar image appeared, the team assumed an error. They changed frequencies. This shape stayed. They scanned again. Same result. A perfect disk, 60 meters wide, resting like it was placed there. That moment shifted curiosity into something heavier, something harder to ignore, something that refused to fade. Long before humans reached this depth, the Gulf of Bothnia followed strict natural rules. Ice covered it for thousands of years. Glaciers moved slowly, pressing everything below. When they melted, they left soft sediment and scattered debris. Nothing sharp formed here. Nothing precise survived that pressure. Every geological model agrees on one thing: this region does not produce clean geometry. That certainty shaped decades of understanding. So how does a perfect circle appear where only randomness should exist? Centuries passed, and ships crossed these waters. Trade expanded. Storms dragged vessels into the depths. The Baltic became a graveyard. Thousands of wrecks settled into the seabed. Explorers began searching for them. Sonar revealed broken hulls, scattered cargo, twisted metal. Every discovery followed the same pattern: chaos, damage, collapse. That pattern held for decades. It built confidence. It created expectation. Until one scan broke it completely. Because what appeared was not broken, it was whole. And that difference changed everything. In June 2011, a Swedish team started a routine survey. They searched for wrecks to document and sell. The process felt mechanical: scan, record, move on. Then something interrupted the rhythm. A circular object appeared on the sonar, too symmetrical, too precise. They marked the location and continued, but the image stayed with them. It refused to settle. It didn't behave like debris. Something about it felt deliberate. So they returned, because ignoring it no longer felt possible. A second scan confirmed the first. Same shape, same edges, no distortion. They changed frequencies again. The circle remained. Around it, the seabed looked uneven and natural, but the object stood apart. Its edges cut cleanly into the sediment. Then something else emerged. Behind it stretched a long groove, straight, uniform, nearly 300 meters long. It looked like a trail, but trails imply movement. Movement implies force. So what moved this into place? Geologists studied the data with caution. The region showed no tectonic instability, no volcanic systems. No known force could carve a straight trench across stable seabeds. One expert described the formation as incompatible with glacial behavior. Ice doesn't move like that. Rocks don't slide in perfect lines. Yet the groove remained undeniable. A path leading directly to the object. A path that suggested arrival, not formation. Something reached this location. But from where did it come? In 2012, the team prepared for a closer investigation. Remote equipment descended first. Cameras struggled in darkness. At that depth, light disappears completely. Pressure rises fast. Visibility drops. But something unexpected happened before reaching the object. Systems began to fail. Signals weakened. Batteries drained quickly. Communication fractured. It wasn't a full shutdown. It felt selective, almost deliberate, like something reacted to observation. Why would a location interfere like that? They tried again using reinforced systems. The outcome stayed the same. Within a radius of roughly 200 meters, electronics stopped working correctly. Outside that zone, everything functioned. Inside, systems degraded without warning. The anomaly didn't just sit there. It affected its surroundings. It created a boundary. That changed everything. Machines could not be trusted. So the team faced a decision. If machines failed, a human would need to go down. A diver descended into near-freezing water. Darkness surrounded him. Only artificial light revealed fragments of the seabed. At first, the ground looked soft. Mud covered everything. Then the texture changed. Hard, uneven. He moved closer. The surface didn't resemble normal rock. It looked altered, almost melted. Then something impossible appeared. Straight lines, clean edges, angles that should not exist here. The environment shifted from natural to something else entirely. He followed the structure along its edge. The circular shape remained consistent. Then he noticed openings, not random gaps, defined forms. One resembled a corridor, another looked like a circular hole with squared edges. The geometry repeated across the surface. Patterns formed. Patterns rarely appear by accident. Patterns suggest intention. Intention suggests design, but design demands a source. So what created something like this beneath the sea? Samples were collected from the surface and sent for analysis. The result seemed simple at first. Basalt, a volcanic rock formed from cooling lava. That should have solved the mystery. Instead, it deepened it. The Baltic Sea shows no recent volcanic activity, no lava flows, no eruptions, nothing that explains fresh basalt. The classification created a contradiction. The material made sense, the location did not. So how does volcanic rock appear where volcanoes do not exist? Further analysis revealed something more disturbing. The material showed signs of extreme heat exposure, not gradual cooling, not natural formation. The structure experienced intense temperatures, sudden, violent, enough to alter its composition completely. That kind of energy leaves traces, craters, shock patterns, residue. But no such evidence exists in the region. The rock exists, its origin does not fit. So what caused that transformation? As news spread, attention surged quickly. Media outlets covered the discovery worldwide. Some reports labeled it a natural formation. Others dismissed it as sonar error. Public opinion fractured. Funding became unstable. Sponsors pulled away. Without resources, research slowed. Expeditions became rare. The anomaly remained unchanged, unanswered. Gradually, public interest faded, but one question refused to disappear. What lies beneath that surface? Time passed and technology evolved. Autonomous underwater vehicles entered the field. These machines operated without constant human control. They mapped environments in high detail. New scans revealed more than before. The structure showed textures never seen earlier. Ridges, layers, repeating patterns. The surface began to look organized, structured, intentional. It no longer felt like random geology, and that raised a new question. Systems usually serve a purpose, so what purpose does this serve? The data grew too complex for manual analysis. Artificial intelligence processed the information. Algorithms tracked patterns in shape and density. Some results pointed to unusual metallic traces in nearby sediment, not common alloys, not typical wreck debris. Something unfamiliar surrounded the structure. The environment itself held anomalies, but no direct sample came from the core. Without that, certainty stayed out of reach, and uncertainty kept the mystery alive. In 2025, a new announcement reignited global attention. One explorer revealed collaboration with an astrobiology specialist. That shift expanded the investigation. The anomaly no longer sat only within geology, it crossed into unknown territory. The framework changed, the assumptions changed. Not confirmed, not defined, but no longer limited to Earth-based explanations. And that shift altered how every new detail would be interpreted. Theories multiplied once again. Some researchers proposed rare glacial formations. Others suggested an altered meteorite impact. Each idea explained part of the evidence. None explained everything. Geometry remained unresolved. Electronic interference stayed unexplained. Heat exposure lacked context. Every answer created new gaps, so new questions emerged. What if the material changed after formation? What if what we see now is only the result of something older? One hypothesis proposed a high-energy event transformed the original material, something powerful enough to rewrite its structure. The original composition vanished, only the outer form survived, like a shell left behind after destruction, a fossil of energy rather than matter. But that raises another question. What kind of event generates that level of energy underwater without leaving a trace? Another theory suggested something mechanical, not natural, not accidental, a structure placed deliberately, then moved. The groove supports movement, the shape suggests design, the repetition suggests planning. But that creates a deeper problem. Who built it and when? No known civilization had the capability to construct something like this beneath the sea. So, are we missing a chapter of history? As research continues, one pattern becomes impossible to ignore. Every explanation solves one piece and breaks another. Each theory introduces new contradictions. The anomaly resists classification. It sits between categories, not fully natural, not clearly artificial, not completely understood. That instability keeps the investigation alive, because unresolved systems demand answers, even when answers refuse to appear. The deeper scientists analyze the data, the less stable their conclusions become. Observations clash with expectations. Models fail to predict outcomes. The anomaly does not behave like a single object. It behaves like a layered problem, one that changes depending on how it is observed. And when no framework holds, understanding begins to fracture. So what happens when knowledge itself stops working? Maybe the real issue is not the anomaly. Maybe the issue lies in how we interpret it. Every attempt forces it into familiar categories, but what if it doesn't belong to any of them? What if the mistake is assuming it must fit something known? That possibility changes everything, because it removes the safety of explanation. Because if every explanation fails, the limitation may not be the object, it may be us. And if that is true, then the Baltic Sea Anomaly is not just something hidden underwater. It becomes something else entirely. A boundary, a signal, a reminder that we may not recognize the unknown when we see it. So what else have we already seen and failed to understand?